Okay, sir. Sir,
Yes.
ntar laptop saya error. Oke, oke, udah. Okay. Good morning, everyone. Good afternoon, everyone. So today, uh, mm, Anjali and I would like to discuss about the uh, research called 3D printed ceramic demineralized bone matrix hyperplastic bone composites scaffolds for spinal fusion. So what is that exactly? So this research discuss about a material that is mixed with ceramics and bone matrix to create scaffolds for spinal fusions. And the combination was because those materials, if it used alone, neither of the materials will suit for the spinal, so they have to combine it together. So these are the examples of the scaffold that they are making, like this small parts, and they have some porous um, layers like that. So the gray one, the circle one, is the HA, or the ceramics, and the um, cream one is the bone matrix.
And for the properties, uh, of course, it needed to be biocompatible, and it also needs to be osteoconductive, meaning that it allows newly formed bones to grow on it. And it also needs to be osteoinductive, in which it promotes osteogenic differentiation or recruitment of immature cells and stimulate those cells down the osteoblastic lineage. And the reason why this scaffold is made from two different materials is because the ceramic hydroxyapatite, or HA, it lacks osteoconductivity and is brittle, but it has excellent osteoconductivity. Meanwhile, the human demineralized bone matrix, or DBM, is osteoinductive, but this osteoinductivity can also be realized when it delocalizes with calcium and phos, phosphoroxide, PO, sorry, PO4 minus ion from that is present in the HA particles. This is why the material must contain both ceramic and bone matrix. Next. For the ceramic itself, the mechanical properties of HA is it has a relative density of 90%. It has a hardness of 4.1 gigapascal and Young's modulus of 110 gigapascal. It also has a fracture toughness of 1.2 MPa, M1.5. Next.
So the application for this scaffolds is that this research was tested to rat's body for specific in spine area, and they studied that the interaction between the scaffolds bones and the tissue, and also if there are new bones detected. And the research was concluded as a success because with a fusion rate approaching 200%. And the research found that the scaffolds that contain more ceramics show greater radiopacity. So um, and also that uh, the ceramics make the new bone that is uh, the new bone is if the ceramics is slowly degrade, they can affect that the creation of the bone. So in the further studies, they want to optimizing the degradation rate. So these are um, the result. As we can see in here, that this is the scaffolds in the spine of rats, um, and these are the results. So these are the reference that we use, and thank you so much.
Group 2, maybe please throw questions to Group 1. Compulsory questions. You have to ask questions. Andy and Grace, please ask question.
Radiopacity itu apa ya? Oke. Thank you.
You have to answer. You cannot just
Yeah.
explain like this.
Okay. Yeah.
Wikipedia
So
is like that.
radiopacity is like the opacity of to the radio waves, so the X-ray can detect the scaffolds itself like that.
Oke.
So why
Thank
is
you.
it important in this?
Because yeah, we can detect that it is already degrade or not, and something like that, because the other one, it cannot detect it, so it cannot be traced like that. So it's one of the most important thing to know if it's success or not.
Okay. Andy, questions? Compulsory questions? Come on, Andy. Otherwise, Group 2 mark will be reduced if you are not asking question. Andy, are you sleeping? Andy, we cannot hear you. I think you have a microphone problem again. Hello, Andy? Yes. No. Nggak kedengaran. Andy, we cannot hear you. You can write your question as in the chat box if you have problem with the sound.
Halo.
Yeah,
Tes.
now we can hear you. What happened just now?
Oh, oke. Jangan ditanya, Sir. Itu eh, kayak bodoh gitu, Sir. Saya bodoh. Apa switch buat mikrofonnya nggak kepencet. Eh,
Okay.
eh, apa ya?
Quick, we don't have much time.
Tadi yang HA itu apa ya tadi ya?
In
Boleh
English, please.
slide-nya Kak? Oh ya, the HA.
HA, yeah.
Boleh, I want to.
What is HA?
So HA is the ceramics called hydroxyapatite.
Hydro?
Hydroxyapatite here.
Hydro
I don't know how to.
hydroxyapatite.
Apatite. Okay. I'm sorry.
What is the formula of hydroxyapatite? The chemical formula.
The chemical formula for that.
Um,
What does it consist of? No Wikipedia, no Google.
C, there is calcium
So,
and there is phosphorus oxide. So maybe
Okay.
I don't know the exact
Calcium, phosphor, oxide.
calcium phosphor oxide.
Yes, and
Um, and and also OH because the hydroxy.
OH. Why did they choose hydroxyapatite for this implant?
um, if I'm not mistaken, it's because the biocompatibility and it's it's suitable to be used with the DBM.
With
To be
the
combined with DBM.
EDM, TBM,
DBM, the bone matrix.
the bone matrix. Okay.
and
And
because
hmm,
yeah, because in the actually the researchers already have previous research about the HA first, so that is why in this research they use also HA.
okay. So why how do they do the 3D printing of HA? How does how is the hydroxyapatite be 3D printed? What is the process there? What is there any melting process? Is there any calcination sintering, or what process do they use in the 3D printing machine to print the hydroxyapatite?
Um, actually,
I thought the screen was frozen.
they no, actually, they just explain about I don't know, maybe we're just coming the research, but what we get is that they just explain about the composites, not the part where how exactly they print that materials. But maybe because we have to read it again, sir. Maybe Angeli, you have maybe you have read that part.
I think it involves some polymers in making of the ink for the 3D printing.
Okay, what type of polymer?
Uh, wait, I'm gonna check. um,
PLG.
LG polylactide co-glycolide.
Polylactide glycol. Okay, I think because of time, thank you for the presentation to one, and we will proceed immediately. Please incorporate the answer to the questions that uh, Tanita, Andi, and myself ask, yeah, into your report later, yeah. Okay, group two is your turn now. If you can present.
Okay. Good afternoon, Pak Didi and friends. So today I and Andi will be presenting about a research that we have read, which is polymer-coated mesoporous ceramic for drug delivery in bone tissue engineering. Next. So this is where we got our we have read our research from from the International Journal of Biological Macromolecules, and these are the authors. Next. First, bone tissue engineering is an emerging field, as we have known, and the main purpose of this field is to restore, maintain, and improve bone tissues, especially the damaged ones. So there is a case in a disease where it is called osteomyelitis, which is caused by an inadequate tissue penetration and a supply of blood, which caused the destruction of bone tissue. It is said that systemic drug delivery failed to cure the disease. So that's why this device is created. So here, as we can see, the ceramics, the mesoporous ceramics is incorporated with polymers. So it could deliver drug smartly because it responds to the stimuli such as pH and temperature change and others. So yeah, it could see the environment between inside our body, and it could tells like when they will release the drug. Here we can see there is the blue one here is the drugs. The red one is mesoporous ceramics. Mesoporous ceramics itself, they have like pores in it, which is 5 until 15 nanometers big. So it is smaller than um, macroporous and bigger than microporous. Yeah, and the picture below here, this is the mesoporous silica. Next. So, why the researchers use mesoporous ceramics for drug delivery? First, it is because the ceramics it somehow resembles our bone structure, our bone, our bone, and ceramics is also used in other applications such as orthopedic implant, bone cements, coating, and others. Yeah, so it matches with our bone. And the mesoporous ceramics has bioactive response. So the external scaffolds of these ceramics are sensible to attach osteoinductive agents such as peptides, protein, and growth factor. When these molecules could attach to the mesoporous ceramics, it could stimulate bone formation, then help in curing the disease that I have mentioned earlier. It has large surface area and pore volume with altering pore size. So this will contribute in the kinetics of the drug delivery. It could control drug delivery, as I have mentioned earlier. It is not toxic. It has low toxicity, which means that it is biocompatible, and it could loads more drug. The ceramics has also good mechanical strength, yeah, even though it's brittle, but it is tough. But I think this mechanical strength isn't really neat when compared to the orthopedic implant, because yeah, actually the function is to release drug, not to maintain or sustain our body like the orthopedic implant. And some examples of the ceramics used based on the research are silica, alumina and zirconia and bioglass. And these materials have their own advantages. Like for example, in silica, silica could load a high quantity of drug and could control the drug release. The aluminum and zirconia could enhance osteoblast adhesion and proliferation of the the tissue cells, while the bioactive glass could also be used in dental, and it could also become a filler material for bone tissue synthesizing materials. Next.
Okay, so as Tanista said, mesoporous ceramics have unique advantages like in drug delivery system, like high surface area and large pore volume, a well-defined pore structure with pore size, good biocompatibility, biodegradability, and easily functions as surface. As for polymers, the good one is natural polymers, greater biocompatibility. Compared with synthetic, it is better, uh, and usually altered for a biological structural response. As for the factors regulating polymers or or mesoporous ceramics in drug delivery, there are pore size, temperature, surface chemistry or modifications, redox responsive controlled drug delivery, pH, biodegradability, cationic and ionic anionic interactions. So for the pore size effect, penetration of the cell, and proper vascularization of the grown tissue. As for the temperature, this is one of the most attractive stimulants for responsive polymer system due to its easy modulation and applicability in drug delivery applications. Um, Among various stimuli sensitive drug delivery system, temperature sensitive drug delivery system provides vast potential due to their versatility in design, tunability of phase transition temperatures, passive targeting ability, and in situ phase transitions. As for the surface, one of the great approach is to take benefit of uh, the surface as an adjuvant to augment the amount of drug loaded and to advance the release kinetics of therapeutics agents under physiological conditions. For redox responsive controlled drug delivery, um, actually, it is great. Uh, it has take a great attention, especially for cancer therapy and bone tissue engineering application among the various stimuli responsive drug delivery system. For pH control, it has functioned as a control and release drug. For biodegradability, um, it represent an important class of materials for drug delivery. For cationic and anionic interactions, it is layer by layer technique based on the consecutive absorption of polyanion polyanions and polycations. It defined as absorbing multiple layers of charged materials. So these are the polymers with mesoporous ceramics, drug loaded specific function in bone. It, this table shows the mesoporous ceramic materials incorporated with polymer of for drug delivery and its specific function in bone tissue engineering. Uh, yeah, I think that's all from us.
Is this a review paper or original research paper?
I think it's a review after I've read it again because yeah.
Okay, yeah. That's why. Yeah, I think I was asking if you could present a more original research, yeah, rather than review, because review then it is too wide. Anyway, questions from group one, Ezra and Anjali, to group two.
Um, how can they combine the polymers and then ceramics and drug together?
Uh, since it is a review paper, it is not said like in detail how they combine the polymers and the drug and the ceramics. Yeah.
Yeah, even though it's not detail, you can mention some of the example how they combine it. Yeah,
Mm.
in some cases of that they have reviewed, what is the method to combine polymer with drugs with the ceramics?
Um, I think there are those informations, but yeah, since we only read the review paper, so we are not aware of those informations. And
Yes, some of those information should be also in this paper, in this review paper, even
but
though maybe mentioned only slightly, not in detail.
they only mention the itu di why is it used, and yeah, and the characteristics only. Yeah, so they only describe the characteristics more than the how they combine
Yeah,
the.
because the title itself is about polymer coating. Then how is the polymer being coated onto the ceramic? There should be some mentioning about that, right? And how is it usually coated? What techniques are used to coat the polymer onto the surface of the ceramics, for example? Can you mention some of those information?
Or Andi, is there the methods in your bagian lu tadi?
There are, I think they just mention about the examples of it being applied, and I think I don't see any methods of they combine it.
Yeah, okay. Can you find it later? Yeah, in your sheet,
Mhm.
because I don't think the answer is good enough. Yeah, to answer Ezra's question. Yeah, that's also my question actually. What is the method? Method is important. Yeah, not only the characteristic.
Mhm.
Methods means the fabrication. How do they coat? By spin coating, for example, or by what? Yeah, please find it. Angeli, any questions?
Previously, there is several types of ceramics mentioned, like glass, silica, and others. Is there any preference based on which to choose which ceramic to use, or it's relatively the same for all ceramics?
I think it is based on the function, like what what they are creating it for, itu, and its compatibility with drugs, like Andi last slide. Yeah, and these are the previous researchers. Yeah, I think it is explained there on their research, like why they choose that material. But I think, but in my opinion, I think it's it depends on the biocompatibility, the compatibility between the drug and the ceramics, and also the polymer.
Okay, thank you.
Clear enough, Angeli, the answer?
Yeah, I get it, sir.
Yeah, because I don't get it. Yeah, need to be explained more, yeah, Tanita and Andy. And my question is, what is mesoporosity here? Why is it important in this particular research work?
Mesoporous itu it is like there are holes, some holes in the molecules in the silica or the other ceramics, which is used to encapsulate the drug. So as why is it why it should be mesoporous, not porous or the microporous? I think it because it contributes to the kinetics of the drug delivery. So it is different between the mesoporous and the porous one. And that's why they choose the mesoporous, because if I'm not mistaken, I have read that the mesoporous one is better when the mesoporous silica is better in controlled drug delivery than the porous silica. That's what
Yeah,
I've
yeah. How
read.
come it is better? Better is just a subjective word.
Yeah.
How do we measure better or worse or good or bad in terms of what parameter?
I think they call response to the stimuli given from our body. That's why they could release like on time gitu loh, on the right time, when compared to the porous ceramics.
What is the size in mesoporous ceramic? What is the
Um,
size of the holes?
5 until 50 nanometers wide, big.
5 until 50.
Yeah.
Why is it not called as nanoporous ceramic, for example?
I think because that's the scale, kayak even the microporous is also nanometers, but below the 5 nanometers that I've mentioned, and the macroporous, the bigger one compared to the mesoporous, is also still in nanometer scale. So I think that's the scale of the pores in the material gitu.
Okay, I think because of time, I would like to conclude until uh, until this. Yeah, I think it's enough. Yeah, thank you very much for Gutu for the presentation. Please later make sure you incorporate the incomplete or maybe not completely answered information, yeah, from the questions, yeah, into your report. Okay, and that will be all for